Good morning, everyone. Dr. Maciel, Bianca, and I will be going over question and answers for the ABWM prep. Basically, try to give you about 5 to 10 minutes of question and answers every day, not to kind of overload you. Maybe you can listen in between patients or at the end of the day. And if you do think about it and something reminds you and you want to go back and look, you can. All this will be posted on Tavuti. Okay. So starting with the first area, we're going to do wound healing environment. As Bianca said in our last provider meeting, this is going to be 23 graded questions in this area. And we're going to start with anatomy and physiology of the integumentary system. So looking at the skin here to the right, what two tissue layers constitute the skin? This is going to be the epidermis and dermis. This is going to be basically partial thickness wounds. Can involve the epidermis and dermis, and we'll kind of get into that a little bit. And then once a wound gets down into that subcutaneous layer, you basically have a full thickness wound. Next question, what is the term for the tissue layer that lies directly beneath the dermis? So the answer to this is actually the hypodermis. Basically subcutaneous tissue, and that's basically where the fat is. You look at the thing, at the picture here, you can see that the dermis is here. It's made up of two different layers. I'm going to kind of repeat myself, so maybe that'll hopefully help you guys remember. There's the papillary dermis, which is the top part, and then there is the reticular dermis, which is the lower part. The papillary has little fingers that project up into the epidermis and the basement membrane. Those are called reti ridges. And those kind of give that skin its integrity. And then the reticular dermis is where you're going to find the hair cells and stuff like that. We'll get into more detail in the future slides here. What is the name for the junction between the dermis and the epidermis? The answer is the basement membrane. So the epidermis is composed of several different areas, kind of going from lowest to highest. You've got your basement membrane, and then the stratum basale, which is where your melanocytes are. And then the next up for that is the stratum spinosum, and you can have Langerhans cells here, and then the stratum granulosum, which is typically where I see Langerhans cells documented. And then on the palms and the soles, you'll have a thin layer of clear tissue called the stratum lucidum, and then above that is the stratum corneum, which is basically all the keratinocytes. So on the palms and soles, this is going to be thicker, obviously. What are the four components of the basement membrane? So the answer is the basement membrane is divides the epidermis and the dermis, like we said. And it's made up of fibronectin, which is an adhesive glycoprotein, type 4 collagen, which for the most part is actually found almost entirely in the basement membranes of the skin, and then heparan sulfate proteoglycan and glycosaminoglycan. So those are the four different things that make up the basement membrane, which separates your epidermis from the dermis. What are the layers or the strata of the epidermis? Kind of like we just went over, but let's do it again. Like I said, I think if we keep repeating it, it should be helpful. So this day we're going to do it from the top down. So stratum corneum, which is that top layer consisting of the keratinocytes. Strata lucidum is the clear layer that you'll find usually on the palms and soles only. Stratum granulosum, which contains keratinocytes as well as Langerhans cells, and then the stratum spinosum, the spiny layer, which consists of, again, Langerhans cells, and then the stratum basale. And that's that basic last layer right before the basement membrane. Typically contains melanocytes and Merkel cells, and we'll get into those in different slides in the future, what those two cells do. Keratinocytes. These are basically cornified epithelial cells that provide the outermost cellular barrier of the environment. They migrate from the wound edge as well as the adnexal appendage structures in partial thickness wounds. So basically, if the epidermis is partially stripped, you'll have these adnexal areas that can actually grow epithelial tissue from within the wound, as well as from the outside of the wound. In a full thickness wounds, keratinocytes migrate only from the free edge of the wound, secondary to damage through the dermis. So basically, there's no epidermis, there's none of these appendages left. Keratinocytes basically will eventually lead to complete epithelialization of your wound. How frequently does the epidermis regenerate? This happens every 4 to 6 weeks. Um, Next question, that's pretty simple there. What pigment produced by the melanocyte is found in the epidermis? So this will be the pigment melanin. It is responsible for contributing to the color of our skin, along with keratin and hemoglobin. It is also responsible for the color in the hair and the eyes. What anchors the epidermis to the dermis? This is what we were talking about before. In the papillary dermis, there are finger-like projections that come out, which are called ready ridges. And these basically form basically a locking mechanism like this that really help to keep that skin integrity strong, prevent skin tears, etc. So in the aging population, this area thins, and that's why they're a little bit more prone to having skin tears and weakened skin. What's the thickest layer of the skin? This would be the dermis. Varies in thickness depending on where you are in the body. The average thickness is 2 millimeters, and usually ranging between 2 millimeters and 4 millimeters. So, getting into some descriptions of the difference between papillary dermis and reticular dermis. Again, the papillary dermis is on top. It's the one that has the fingers, red ridges, and then the reticular dermis is the lower one, where basically you're going to have collagen fibers, strength, flexibility, sweat glands, hair follicles, etc. So, in the papillary dermis, this is composed of collagen and reticular fibers. The vascular supply is from the deep plexus. Ironically, the reticular dermis, which is below, is actually supplied by the superficial plexus. No. Um, and the papillary dermis contains pain and touch receptors. So Meissner's corpuscles or Pacinian's corpuscles. So basically, I would remember pain and touch, papillary dermis, ready ridges, papillary dermis, reticular dermis is where you've got the sweat glands, hair follicles, blood vessels, nerves, if that makes sense. The reticular dermis is going to be the thicker of the two. What is the location and function of the fibroblast? So, fibroblasts, super important in wound healing. They originate from fibrocytes that arise from the dermal layer. They're attracted to the wound environment by platelet-derived growth factor that's secreted by platelets and macrophages during the hemostasis and inflammatory phases of wound healing. So you've got the four phases: hemostasis, inflammatory, proliferative, and remodeling. We will definitely get into that in future slides. So fibroblast migration is mediated by binding fibroblast integrins to the cell adhesion molecules, CAMs, in the extracellular matrix. They're able to remodel the extracellular matrix through production and secretion of multiple different proteases, including matrix metalloproteinases. We'll definitely get into this in terms of chronic wound healing, which matrix metalloproteinases are actually helpful for wound. They help clean up, they help things get going. But in a chronic wound, they can get basically too high levels, and this can lead to wound chronicity and leading to a wound not able to heal. Um, Once fibroblasts arrive in this provisional extracellular matrix, they begin to proliferate and deposit a new collagen-rich matrix. So super important in creating granulation tissue and moving a wound from the inflammatory phase into the proliferative phase. What factors stimulate fibroblast proliferation? So we're basically talking about different groups of growth factors here, including, like we said before, platelet-derived growth factor, there's epidermal growth factor, and then fibroblast growth factor. And then another thing is that hypoxia at the wound center will actually increase the amount of fibroblasts in the wound. And as neurovascularization proceeds and you get more and more healthy granulation tissue, the hypoxia stimulus for fibroblast proliferation decreases and you decrease the number of fibroblasts in the wound. Fibroblasts play a key role in the extracellular matrix deposition of which type of proteins? The main one here is going to be collagen. So the matrix is mostly made of collagen, but you've also got elastin, reticulin, proteoglycans, and glycosaminoglycans. So that's it for today. Stay tuned for episode 2. And if you need, you can go back onto Voodie and kind of re-listen to this if little things come up during the day that you want to remember. But the best way to do this is kind of listen to it a few times, get it in your head. And then as we keep going on, you'll see these things keep popping up. So I hope you guys have a good day. Take care.